What's up, everybody? How's it going? Let's do another LEET code question. Longest palindromic subsequence. Given you want to find the longest palindromic subsequence's length in any string given to you. The string's length could be 1,000. So that immediately tells us you could do n squared. All right. Let's give maybe this a go. N squared. Well, if we try to do it by brute force, we could try deleting every possible combination of letters and then going to see if the resulting string is palindromic or not, but that's going to take too long. So we're going to have to use dp. What would the dp be? So let's say the subproblem is dpij equal to, well, we can start with the simplest kind of subproblem and what's the longest length of longest palindromic in substring I to j. Then let's see if this works. So transition, assuming that we have this subproblem for a particular length, as in if L equal to j minus I or j minus I plus 1, then what can we do with that? Well, that depends. If the first case would be if s at I is equal to s at j. So what do I mean by that? BBBAB I to j. Alright, so this is where our I and j are positioned. We see that s at I and s at j are equal. They're both b. So what can we do? Well, we know the answer to every substring of small length. So that includes this I and j. Now this I and j, just by looking at it, we can see that the answer would be 2. If we delete the a, then we get this palindrome here, bb. So it will be 2 plus, because I and j are equal at these positions, it will be 2 plus 2, which is 4. And that's the answer for this. Or it could be that the answer is we don't even account for the right endpoint and just move j down 1 and take whatever answer here is, because we know the answer already. We're assuming we know the answer for this because the length of the substring is smaller, and the answer will be 3 in this case. Or it could be this, and the answer will also be 3. So a max of 4, 3, 3 is going to be 4. Right? So this would be the max of dp I plus 1, j minus 1 plus 2, or what was it? dp at I plus 1, j, or dp at I, j minus 1. Okay, the other case, of course, is if they're not equal. Then if they're not equal, then we can't do the thing we did where we just take this plus 2, so answer of here plus 2. We can't add 2 because, obviously they're not equal. I and j here aren't equal, so we just remove this case, but the other two cases can still apply. So that's pretty much it for that. And now we just have to think of a base case. We have to think of the boundary here. So we probably want to handle the cases where j minus I is equal to 1. So if the length of the substring is 1, any letter on its own is a palindrome of length 1. Case j minus I is equal to 2, then it could be either 2 or 1. Well, it's 2 if s at I is equal to s at j. So if I actually take this, the value is 0, 1. If I add 1 to that, it's basically saying if they're equal, then we have a palindrome of length 2. Otherwise, if they're not equal, this will be 0, so it will be palindrome of length 1. We can code this out. Auto vector, initialize everything to 1. Call this dp. For each length, starting from 1, L less than S dot size plus plus L. Then go through I equal to 0, I less than S dot size plus plus I. So our j would be equal to I plus L. And if j is greater than or equal to S dot size, then we're over the boundary, so we can just continue. Otherwise, L is equal to 1, set dp ij be equal to s at I plus 1, continue. And then we also know that dbij should be at least max of dp of I plus 1, dp I minus 1. But if si is equal to s of j, then we want to say that dpi is equal to the max of itself, or dp at I plus 1, j minus 1. And then we return dp at 0 dot size minus 1. Okay, this return has to be here, and we've got the j here. Give that a go. Alright, submit that. Yeah, nice. Okay. Hope that was helpful. And if it was, give it a like. And I'll see you in the next video.